In today's video, we're going to be looking at the Launch Kontrol Pulse firing system. This is the wired system, which is probably the cheapest firing system on the market you can find, but it actually has some really great features and some great design ideas behind it. So this is the original version, I think, because I don't have this version. I think this is the first one they did with the freehole components. It's a really nice design, it fits well in your hand, and you can see it's quite clearly labelled. This is obviously a single-sided PCB, so this front side is actually the PCB, so everything is mounted on the PCB, and then the back side obviously has the tracks for the actual circuitry. So you can see they've made that in a small plastic case, so it's a really good lightweight product. The battery is accessible as well, and the concept really is that you use the same wire over and over and over again, but you change the tips, the heads, the igniter heads, because their research was basically saying that the money you spend on talons is actually mostly the cable. So therefore you can buy them cheaper if all you actually do is replace the heads year on year. And we'll get into that maths a bit later to see if they actually managed to achieve that business model or not. But it's a slightly different idea to other ideas on the market, so I quite appreciate this concept. Now, if we actually look inside the igniter head itself, it's a bit more complex than the standard talon igniter, because obviously you've got the header that fits into the wire that you're going to reuse. Then you've got the nichrome wire going against on a PCB, and you wouldn't normally find a PCB in a talon. This is a much more costly thing to produce, and this is it inside the plastic shell. You can definitely see the circuit board there and the nichrome wire, so this has more sort of manufacturing elements than a standard talon. So this is a standard talon. You can see actually the wire comes straight in and then goes to two posts with a nichrome wire fed with routine. So this is a much cheaper way of manufacturing the same thing. So the question is, can they still get this product at the price point? Now, if we move to what system I've got, this is the system I've got. You can see this is actually now all surface mount components rather than through hole components. And they've changed the way they've designed the board. So you see this is a black solder mask, and the writing, the logo in that is actually on the copper. So this has been level soldered, as well as obviously the PCB pad. So they've masked the masks technically to get all their writing on there, which means you get a nice shiny silvery writing rather than the usual sort of white silk screen that looks a bit tacky, which I think is a quite nice alternative. So basically you press this button at the top and that puts power into the system. That sets the arm light on, and it also feeds power to the igniters. And if the igniter is in and completes the circuit, you'll get a light next to the channel that igniter is connected to. And then to fire, you simply press the fire channel button, as well as keeping the arm button depressed, and that will send fire and current to the system. Now, I'm not going to do this as like what I've done previously, where I show you the circuit board and I draw out how I reverse engineer it, because this is a very, very simple circuit. So we'll jump straight to the schematic. So let's jump into the schematic. So here's the schematic straight away. Now, if we see we got the 9-volt battery obviously connected to the switch, which is the arm switch. So you press that switch down, and then obviously current will flow to the arm LED, and then to the module extenders, which we'll talk about in a second, and then to the RJ45 connector. Now, obviously, that then comes back from the other side, the RJ45 connector. There's an igniter obviously connected, bridging the two pins to the fire and continuity tester. So the continuity tester simply has an LED constantly in series with the igniter channel, and that will light up obviously as soon as an igniter gets put in and completes the circuit. So on this case, for example, this is between pins 2 and 1. So you can see on the other side that if you get an igniter that sits between pins 2 and 1, you'll complete the circuit. So the 9 volts will come up from 2, round the igniter, back through 1, and then 1 goes to the fire circuit. And it goes obviously through the LED for continuity wise. And then when you press the fire button, all you're doing is you're shorting that igniter straight to ground. So that's where you're getting the massive current flow, which will pop the igniter. Now the module extenders allow you to put other modules onto this system and extend it with the same battery. There is some videos on YouTube of this happening, and you can see here, after a bad shot, my apologies, but you can see somebody's extended the system by a number, about 16 modules. Is that right? 1, 2, 3, 4, 5, 10 modules. And you can see they've got one battery that runs all of these modules. So the idea being that you press the arm button on this module, and then all the others will power from this one module. Now, one of the problems I've got with this system is if you look here, that although you have fire 1, 2, 3, and 4 on the module, you actually have colors on the igniter clips. So if you look, here's the header blocks you put into the igniter clips. They're actually colored rather than numbered. So you're never quite sure which actual queue you're in. And if you look at, this is from Jordan's Fireworks, which is a big retailer in the UK, they've actually had to put on the website what each number relates to what color, which is ridiculous really. You would think you would just number the connectors rather than color them. This is a typical moment when probably the first system they designed, they didn't bother coloring or numbering. And then they thought, oh, they need to find some way of making sure you know which queue goes to which header. And maybe costly, it was too costly to number them, so they thought we'd color them instead, and that will solve the issue. And it doesn't really, it just creates more confusion. Now, if you have a quick look at the board with the switches and the batteries connector off, you can see here that this is the silvery text I was on about, which is of course the same as the pads. That's all on the copper layer and then soldered across to create that silver. The silk screen, you can see that it's got the actual part numbers on, which is that white text. Now that is covered up, and the resistors are covered up by the battery section. So they've sort of neatened the design up by hiding some of it. So that's quite a cool idea for design, to try and get rid of the components which make your item look ugly. So let's have a quick look at this extendable modules thing, because this is actually quite important. So it states in the user manual that batteries can be added at intervals for extra fire and power. Boards can be fired in any order. Do not use carbon-based batteries, okay? So now let's assume we've got 3 fire modules. And if you look, I've connected cables between the headers. So we've got a header that goes from here to the middle one, firing 2. Now, fire module 2 does not have a battery in. Then I'm using the output header to connect to the fire module 3. Now, fire module 3 does have a battery. But some of you may notice the problem with this whole system is that if I press ARM button on fire module 1, sure, that battery will then power the other modules. But the battery in fire module 3 is not even connected. So unless you press that ARM button as well, there's going to be no extra power given to you by that battery or any other subsequent batteries. So what they don't tell you here is that if you want to connect this to the circuit, you're going to have to hold every ARM button of every module that has a battery in it. Because if you don't, you're not going to get any parallel effect of any of the other 9-volt batteries, because they won't be connected to the circuit at all. So that is a slight drawback of this system. So let's jump straight to the overview really, because there's not much to discuss. It's a really simple system, and I do quite like it. So one of the pros, PCB part numbering. So I criticised Ignite for this, so I should really show you what they've done here. So you can see, if you look, you can see what they've done here is that they've matched the resistor numbers with the diode numbers as well. So for example, diode 2 is on resistor 2, diode 1 is on resistor 1, etc, etc. So everything makes sense in this. If you look here, so diode 5 is with R5. I mean, they've labelled it in a way that makes complete sense, which unfortunately Ignite didn't really do on their system. So let's have a quick look. The text is not silkscreen, it's that wonderful copper which has been soldered, so it looks lovely and shiny. I really like that. Cost saving igniters due to wire reuse. Now this does happen if you look at the igniter costs. So I looked at 25 times 0.5 talon igniters in the UK. It's roughly £10.99, so 43 pence per igniter. Whereas a 20 times LK Pulse refill is £7.49, so that's 37 pence per igniter. So you've got a 5p saving, so it is sort of working, but nowhere near the amount I was sort of hoping really. And that's probably because of the manufacturing costs of putting a PCB inside every igniter as well, and putting the header, etc. That's going to add up. Unfortunately, there needs to be a slightly cheaper way of achieving that process. So it's really simple to use and explain. The layout fits nicely in the hand and accessible by the things. And I mean that you can use the same hand to possibly fire it if you wanted to, or use 2 hands. And of course it's expandable, which is nice. Cons. So the batteries do not parallel unless ARM button on each module is pressed, which they don't mention. I say that's quite a big con. The LEDs, now this is the interesting point for me for the colour of the LEDs, because if we look at the system here, so when you press the ARM button, you have a green LED, and then when you've got continuity, you get a red LED. Now there's no system, as far as I'm aware on the market, other system that is, that uses this colour coding. All the other ones will use a red LED for danger, for arming, and then a green LED to show you have good continuity. So I'm not quite sure why they chose to reverse that. That seems completely illogical and against the rest of the market. So now you have to educate your consumer, which is always a downside to doing things like that. Now the igniter LED is obviously coloured, but the Qs are numbered. That absolutely makes no sense to me. That needs to be changed really. But the logo and legend also are connected to the ground plane. That's one of the downsides of doing what they've done, because there's no isolation between the text. So like fire-free text is actually got continuity with the ground plane because it's on the ground plane. That is the ground plane. So maybe they should have put an isolation track around it to prevent the actual text from being ground. Because it means if you get like a battery source and you touch that text, you could potentially cause an issue. So that's something to be aware of. In terms of module costs, so the 4K LK Pulse module is $24.99, roughly $6.24 per Q. The 4Q DB04R, if you bought it in the UK, is $34.99, so that's about £8.74 per Q. Obviously the 6Q Ignite Light we did last video works out about 13.33 per Q. Now the 32Q, MS32Q, works out at £7.45 per Q, but obviously it's £238 to buy as a module. So you can see actually that in terms of cost, the 4Q LK Pulse and the 32Q is actually very similar price points. So something else that I really like about this system is it's adaptable and you can mod it. So what I've done is that I've taken this system and I have added coloured buttons that are the same as the end of the igniter heads. So now you're not worrying about the numbers, you're worrying about what colours you're plugging into. And I've also changed the LEDs, you'll notice, so the green LEDs are for continuity and you've got a red LED for arm. Now I just want to quickly show you how this sets up in the field, because there is another photo that I took from YouTube. This again is from Jordan's Fireworks, and you can see what they've done is they've split the cables up. So you've got a nice long length of cable per each igniter, and that's how you wire it to the system. So overall it's a really neat system. I really like it. I hope to use it in my demonstrations because I think it does really work really well, particularly after I've made those slight adjustments to it to say that now the colours match up and you can just make sure that you're firing red and red, etc. So that's the LK Pulse system.